I started it.
But let's go ahead and do that, and then we will take our quiz. Oh, you started? Okay, thank you. So here we go. I didn't put the directions down, so I'll kind of give you the directions as we go. Simplify. Okay, so you look at this and you say, whoa, 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 here's a negative exponent. So what are you going to do with it? Move it up. All right, so up it goes. So I've got my x cubed and my y to the fifth, and now I have a y to the third. Does that look okay? All I did was move the y with the negative exponent up to the top. All right, now we start simplifying anything that we can. There's a 2, so I guess it'll just stay down there because there's nothing to combine it with or cancel it with. What about our x's though? Take a look at that situation. What do you think's going to happen with the x's?
So we'll put x to the fifth on the bottom.
We'll put x to the fifth on the bottom. And again, I don't know how you think about that, but how I think about it is like this. I have 3 on the top and 8 on the bottom. The bottom has 5 more. So I'm going to have x to the fifth down there. Now what about the y's? The y's are not on top of each other. They're right next to each other. So I got 5 y's and 3 y's, which means altogether I have 8 y's on the top, right? And there's our answer. Good? All right, now we're sketching this one. So there'll be a little number line there for you, and you're just going to put it right there on the number line. There's only one number in this one. Sometimes there's 2. This one only has 1. So I'll put that one number right there. Now tell me, what about it? What do I do? Shade it in, and that's colored in because we know the bracket means closed dot. What means open dot? Parentheses. Okay, now there's an infinity. Now what kind of infinity is that? Well, it's a positive infinity, and positive infinities are that way. So we just shade in the whole number line, including the arrow, to the right. Got it? Write this one in interval notation. We're going to write this as an interval. Remember, the parentheses and the brackets, that's what we mean by interval notation. So what would this look like in interval notation? David?
Parenthesis 5, 7 bracket.
Perfect. Everybody okay with that?
Yes.
Now, we don't have to graph this one, but if we did, we'd have 2 dots on our number line, right? One at 5 and one at 7. The 7 would be colored in. And where would the shading be? In between. Remember, it's always in between the 2 numbers. If you've got 2 numbers like that. Okay? Now, what property is this? This is a property. Which property is it? That's distributive. This is the distributive property. Some other properties we talked about the other day. What property is this? Anybody remember? We had this one on our notes. That's the additive identity. And this one is the multiplicative identity. When you get the same thing you started with, it's an identity property, and this one's an add and that one's a times. What about this? What property is that? Commutative. Commutative. Why is that commutative? Because the order changed. Commutative is order. Order. As opposed to this, which is not commutative because no order changed. That's associative. Notice 3, 2, 5, 3, 2, 5. The order didn't change. It's only commutative if the order changes. All right, over here, scientific notation. Write that number in scientific notation. 1, 2, 3, 4, 5. So 5.83 times 10 to the 5th. Right? Additive inverse. What is the additive inverse of this number right here? Additive inverse. Jacob?
-3 minus 2 square root of 7.
Exactly. When we say additive inverse, what are we talking about? Opposite. So in other words, we're just going to change the signs.
We never do the square root, no.
What do you mean?
Like the 7 times.
No, because this is a term and this is a term. So that's not separatable. Now, if it were 5 minus root 7, then it would be -5 plus root 7, because this is a standalone term. But here the whole thing is the term. All right, and then we got a fraction here. Rational or irrational? Well, it's rational. And if you're unsure about that, you can do the division. So 4 into 15. And remember, a rational number is a decimal that terminates or repeats. So if you take your fraction and you divide it out, and it either gives you something like 0.66666 or repeats, or it stops, this one stops, right? Done. When that happens, it is a rational number. You can tell irrational numbers a mile away, irrational, because they're things like this, right? Or pi. All right. Time for our very first quizzy poo. Now, what I need to know, does anybody have a birthday today? A birthday. Is this your birthday today?